All right, so let's start off by evaluating these. What is 3 to the 4th? So what is 3 times 3 times 3 times 3? Well, 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. What about 3 to the 3rd? 3 times 3 is 9. 9 times 3 is 27. What about 3 squared? 3 times 3 is 9. 3 to the 1st is just 3. And 3 to the 0 is 1. So what's happening when we go down to each one? Well, they're being divided by 3, right? So that's going to be the same thing. We're going to do divide by 3. So now instead of a number, it's going to be 1 divided by 3 because it's 1/3, right? Okay, so that's going to be our property now. So our property is anytime we have a negative number, it becomes 1 over that negative. So if it's like a to the negative 2, it becomes 1 over a squared. So anytime we have a negative exponent, it always becomes a fraction. Okay, so let's look at a couple of these. So write each expression with a positive exponent. So what that means is just use the property above. So this is really 1 over 3. And 8 to the negative 1 is 1 over 8. And x to the negative 1 is 1 over x. What do you think 4 is? M to the negative 3. Well, it'd be m to the 3rd then. Okay? So anytime we have a negative exponent, it gets bumped down and becomes a fraction. So let's look at example 2 then. So it's 3 to the negative 2. So that becomes 1 over 3 squared. But it says evaluate. So we need to figure out what 3 squared is. And that's 9. So I want you to do 2 and 3 now on your own. So I want you to pause and do 2 and 3 on your own for me. All right, so hopefully you got 1 over 125 for the second one. And then the third one, you got a positive 1 over 81 because it's negative 3 times negative 3, which is a positive. Negative 3 times negative 3 is a positive. Positive times a positive is a positive. Okay? Example 3 says write each fraction as a power using an exponent other than negative 1. So we're pretty much doing the opposite of example 1. So in example 1, we turned these things with exponents into their evaluated fractions. Now we want to take their fractions and write it as a power. So this is now 3 to the negative 2. And this is x to the negative 8. So I want you to pause and try 3 and 4 for me. All right, so this is where knowing our perfect squares is really going to be in handy. Because you would think that it would be 25 to the negative 1st, right? Because that's kind of the pattern we've been doing. But the directions say using an exponent other than negative 1. So then you would have to know that 25 is 5 times 5. So that's why it's 5 to the negative 2. Because 5 squared is 25. And same thing for 4. So this is 7 to the negative 2 now. All right, last one is that we're going to take the past two properties that we've learned, and you're going to apply it with negative exponents. So we're going to take these negative exponents in example 1, and since we're multiplying straight across, we use the property that means we add our exponents. So that means that answers 2 to the 4th. I'm going to skip number 2. And then we're going to do example 3. So when we have fractions like this, we subtract our exponents. So we have x to the negative 2 minus 6. And this is x to the negative 8. But we can't leave an exponent negative. So now we have to take this x to the negative 8 and put it as x over 8 to the first. Not 8 to the first. As x to the 8th power. So we have to write that as 1 over x to the 8th. And now that's our answer. So now I want you to pause this video and try questions 2 and 4. Okay, so pause right now for me. All right, so hopefully you got x to the 8th and x to the 16th. So 4, make sure you have a good sense of your rules because it should be 12 minus a negative 4, where you do either slash slash or keep change change. Okay, so please let me know if you have any questions the next time we're in class together.